Hi, this is Prashant Bharadwaj. Today we'll be talking about the inputs to MRP, Materials Requirement Planning. There are 6 major inputs and planning factors to execute Materials Requirement Planning. As you may recall, MRP, or Materials Requirement Planning, is basically the planning of requirements of all the materials, raw materials, components, work in process, and finished goods, sub-assemblies, everything. So for you to determine when and how much of all these raw materials and components and sub-assemblies and end items, you need these inputs and planning factors. What are they? Number 1 is the master production schedule. The master production schedule, we have spent a lot of time on that, which typically looks at the end item demand. So I will not explain that in any more detail. If you want to learn more about the MPS, please go to the module on MPS. But all I want you to realize is the MPS, which provides the end item demand, is the driver of MRP. Let's move on to the bill of materials. The bill of materials is also referred to as the product structure tree. It provides the parent-child relationships. Let us try to understand that with this picture of a bill of materials or a product structure. This is an example of one of the most straightforward products, a simple chair. The chair itself is made up of a seat, arms and legs, and what you see in parentheses is the number of units of arms and legs required in a chair, that is 2, glue, and the back of the chair. The seat itself is made up of the frame, the cushion, the fabric, and the tacks, the fasteners. The back itself is made up of the frames, the cushion, the fabric, and the tacks. You also see in some of the bills of materials the lead time required for each of these. So 1 week here refers to how long it takes to put the seats together. 2 weeks here refers to how long it takes to put the frames together. 1 week here refers to how long it takes to do the final assembly of the upholstered chair once these 4 are available. Now, the bill of materials is like a recipe. It tells you what goes into the final product and in what sequence. This is critical. At the end of the day, MRP tells me how much to make, how much to order, how much to produce of all of these. Secondly, it will tell me when to order and when to produce all of these things. So a major input to that is the product structure or the bill of materials. Now, this is one of the simplest products you can imagine, but a bill of materials is necessary whether you're making a computer or a car or even an aircraft. So you can imagine the complexity of the bills of materials for a car or an aircraft. So there are different types of bills of materials called modular bills of materials, phantom bills of materials. I will not go into too much detail, but I just want you to know that bill of materials is basically a simple way of identifying what goes into the end item, in what sequence, and how many. Now, let me explain one nuance of the bill of materials, which is very critical even for simple MRP execution. That is the idea of low-level coding. Let's look at this hypothetical product A, which requires B, C, D, E. B in turn requires F and G. D in turn requires G. E requires J. G requires I and J. G requires I and J also. Now the parent of B is A. The parent of C is A. Parent of G. What are the parents of G? Look at where G is in this bill of materials. G is here. It belongs to the item B. So B is a parent of G. So is D. So G has two parents. How about J? J has one parent E here, another parent G here in two places. So it is conceivable that a product is required in 10, 12 different subassemblies. So a component can have multiple parents and a parent can have multiple children. So that terminology is used routinely in bill of materials, the parent-child relationship. Now if I ask you a simple question, how many item J's are required in 1A? Think for a minute. How many J's are required in 1A? Pause this and think and then listen to the answer. So you need 2 J's in 1G, 2 G's in 1B, and 2 B's in 1A. So you need 2 times 2 times 2, 8 J's in 1A in this route. Now J is required here also. You need 2 J's in 1G, 5 G's in 1D, 3 D's in 1A. So you need 2 times 5, 10 times 3, 30 J's on this side. So you need 38 J's. Is that clear? Good, you caught me. You need another J here. 4 of J in 1E, 1E in 1A. So you need 4 more. You need 42 J's. Now, this was not too difficult to understand because this is a simple product. Now, if this bill of material was for a complex product with hundreds of components and subassemblies and end items, it would be impossible for a human mind to calculate the way we did in this example for item J. In that case, we use the concept of low-level coding to determine the sequence of planning for these items. Now there are how many items here? A, B, C, D, E, F, G, I, J. There are 9 items. Now what is the sequence of planning for these 9 end items, subassemblies and components? Which one do we start with? We always start with the level 0. We call this level 0. Level 1, 2, 3. Now we look at item A. Does it appear in any other place? No. It appears only in level 0. So the low level code of A is 0. The low level code here is 0 because A appears only once in level 0. Now look at B, C, D, E. Do they appear in multiple places? No. They appear only once in level 1. So the low level code for B, C, D and E are all equal to 1. How about F? F appears only once but in level 2. So its low level code is 2. G appears twice. Where? G appears twice both in level 2. So the low level code for G is 2. Now, so far it was straightforward. Now let's come to J. Where does J appear? J appears once in level 2, but it again appears in level 3. So what is the lowest level in which J appears? It is level 3. So low level code for J is 3. Low level code for I, it appears only in level 3. So you have the low level code for I as 3 also, because it appears only in level 3. You plan MRP, that is how much to order and when to order, or how much to produce and when to produce, based on the low level codes. So you start with the items with low level code 0 first, so which is A, followed by all the items which are in low level code 1, which is B, C, D, E. They can be done in any sequence, but they cannot precede A. Then the only two items which have low level code 2 are F and G, followed by I and J. So there is no way you can plan for J unless you are done with G. Why? Because it is in low level code 3, this is in low level code 2. Now why is that important? G is a parent of J. So unless you know the requirements of G, you would not be able to determine the requirements of J. That you would have figured out even without low level coding in this simple example. But if it was a complex bill of materials, you would not be able to do that. You would have to resort to identifying the low level codes of all the hundreds or thousands of components and subassemblies and end items, and then start planning from the highest level, which is 0, all the way down. Now going back to the inputs to MRP, we understand the master production schedule, the bill of materials. MPS tells you the end item demand typically. Bill of material tells you what the end item is made up of, in what sequence. Now the third one is the inventory record or status or master file. It is basically a computer file or database which has up-to-date and accurate inventory information. So in this example, how many chairs do I already have on inventory of this particular type? How many seats do I have? How many frames do I have? Whatever I have in inventory will be reported in the inventory record file. So you can take that into account while deciding how much to produce or how much to procure. These are the three major inputs to MRP. Now if you move to the three planning factors in MRP, which are also very important before you execute MRP. What are they? Number one is lot size. The most straightforward one is L for L, lot for lot. When I say straightforward, easy to understand, but certainly the most difficult to implement. What is L for L or lot for lot? Produce any amount you need. So if I need only 23 units to meet the customer demand, I produce only 23. If I need only 47 the next day to procure of a different item, I procure exactly 47. That is lot for lot. Later in JIT or lean, we will discuss that in more detail, but for now, let us understand that not every company finds it economically feasible to order whatever quantity is required. So they resort to a particular lot size or a batch size or economic quantity to order. We will discuss this in inventory control also when we talk about economic order quantity. What is this FOQ? Fixed order quantity. It means what it says. That is, you order all the time a specific fixed quantity that you have planned in advance. This quantity may be based on the supplier's requirements. This may be based on the constraints of transportation. Whatever the case is, you have a fixed quantity, let's say 200. Even if you need 145, you order 200. You need 75, you order 200. Let's look at lot size multiple. Again, the name tells you what it is. Let's say, for example, it is lot size multiple 50. Then if you need 45, you order 50. you need 35, you order 50. If you need 72, you order a multiple of 50 closest but greater than 72, which is obviously 100. So if I need 135 and I'm using lot size multiple 75, I would order 150. Finally, one more example. If I'm using lot size multiple of 60 and I need 165, I would order 180. Similarly, you have minimum lot size and maximum lot size, which tell you that you cannot order anything less than a particular amount or more than a particular amount. You have periodic order quantity, which means you order every 2 weeks, for example, whatever you need for the following 2 weeks. So here the lot size is not based on the quantity, but it is based on the frequency of ordering. So these are some examples of lot sizing, which is crucial in MRP because you need to know how much to order. It is based not only on the requirements but also on the lot sizing policy that you are using. And this is important, etc. here, because there are many more heuristics and methodologies of lot sizing. We will not get into any more details in this particular class. Then you have lead time. You want to know how long it takes to procure or produce every single raw material, component, subassembly, and final assembly. These are obviously not exact, but you gotta have a pretty good estimate, because like you will see in MRP, the whole idea is time phasing the requirements of the production and procurement. Now, what is lead time? Lead time is not just the processing time. Processing time is the time that the product spends in the hands of the worker or the assembly person or on the machine. That is only a small fraction. That is the only value adding component of lead time. There are several non-value adding components of lead time. You got to set up the machine. If you are changing from the production of one particular product to another product, you got to set up the equipment, set up the tools. If you're ordering parts, you need to place an order. There is an ordering time. Things won't be done instantaneously. Even when the product comes in, it may have to wait before it is processed. Either wait for the employee, wait for the machine, or wait for the material handling. Whatever the case is, the queue time. It may be put in storage and then retrieved later. The product needs to be transported if it is a supplied product. If the product goes through different stages in production, there is material handling time. Lead time is a combination of all of these. The closer it is to just the processing time, the better, because that is the only value adding component. There is no value added when it is being transported, when the machine is set up, when there is waiting, inspection, all of these. But the company needs to have a good idea of the lead time, the time from start to finish for every raw material, component, subassembly, and final product. Finally, the planning factor in MRP is the safety stock, which some people sarcastically refer to as just in case. What do you mean by a safety stock? There is a slight nuance between safety and buffer. For our purposes, let's assume it to be the same. Buffer or safety is the extra inventory that you keep just in case your demand and production don't turn out to be as planned. Simple. If your demand turns out to be more than what you thought it was, you better have some safety stock. If your production happens to be less than what you originally thought, you better have some safety stock. So for these contingencies, you plan to keep a safety stock. Later in just-in-time and lean again, we will discuss the drawbacks of safety stock. But for now, let us understand that it is the lifeblood in many companies. So in essence, you have the three planning factors: lot size, lead time, safety stock, and the three inputs: the driver of MRP, the MPS, the bill of materials, which tells you what the end item is made up of, and the inventory master file or status file or record file, which gives us how much of inventory we have of every